Hello and welcome to today's session. In today's session, I am going to make you familiar with Naive-Bayes classifier. What is Naive-Bayes classifier? Naive-Bayes classifiers are a collection of classification algorithms based on Bayes' theorem. It is not a single algorithm but a family of algorithms where all of them share a common principle, that is, every pair of features being classified is independent of each other. To start with, let us consider a dataset. One of the most simple and effective classification algorithms, the Naive-Bayes classifier, aids in the rapid development of machine learning models with rapid prediction capabilities. Naive-Bayes algorithm is used for classification problems. It is highly used in text classification. In text classification tasks, data contains high dimensions as each word represents one feature in the data. It is used in spam filtering, sentiment detection, rating classification, etc. The advantage of using Naive-Bayes is its speed. It is fast and making prediction is easy with high dimension of data. What is called Naive-Bayes? The naive part of the name indicates the simplifying assumption made by the Naive-Bayes classifier. The classifier assumes that the features used to describe an observation are conditionally independent given the class label. The Bayes part of the name refers to the Bayes part of the name refers to Thomas Bayes, an 18th century statistician and who formulated Bayes' theorem. Assumptions of Naive-Bayes. The fundamental Naive-Bayes assumption is that each feature makes an feature in independence. The features of the data are conditionally independent of each other given the class label. Continuous features are normally distributed. If a feature is continuous, then it is assumed to be normally distributed within each class. Discrete features have multinomial distribution. If a feature is discrete, then it is assumed to have a multinomial distribution with each class. Features are equally important. All features are assumed to contribute equally to the prediction of the class label. No missing data. The data should not contain any missing values. Now, let me demonstrate a Python program in which I have implemented Naive-Bayes classifier. So, firstly, let me execute this Python program. Now, let me break down this Python program in which I have implemented Naive-Bayes classifier. First, data setup. Define a dataset of emails with spam and ham labels. Pre-processing. Convert labels to numeric values and split data into features and labels. Train, test, split. Splitting data into training and testing sets. Vectorization. Convert text data into a numerical format using count vectorizer. Model training. Train the Naive-Bayes classifier on the training data. Prediction. Predict labels for the test data. Evaluation. Measure the performance using accuracy and a classification report. Now let me explain the output. First point is accuracy, the percentage of correct predictions in the test set. Second point is precision, the ratio of correctly predicted positive observations to the total predicted positives. How many predicted spam were actually spam? Recall, the ratio of correctly predicted positive observations to all observations in the actual class. How many actual spam were correctly predicted? F1 score, the weighted average of precision and recall. It's a balance between the two. Now, things to keep in mind. Small data set. In real world scenarios, using a very small data set like this will likely lead to overfitting. Consider working with a larger data set. Second point, text preprocessing. For more complex data sets, consider adding text preprocessing steps like removing stop words, common words like the, and, etc. that don't contribute to meaning, stemming, or to reduce words to their base form. Third point, evaluation. The evaluation metrics might be more informative if the data set was larger, especially in terms of precision, recall, and F1 score. Now The next point is advantages of naive-Bayes classifier. Easy to implement and computationally efficient, effective in cases with a large number of features, performs well even with limited training data. It performs well in the presence of categorical features. For numerical features, data is assumed to come from normal distributions. The next point is disadvantages of naive-Bayes classifier. Assumes that features are independent, which may not always hold in real-world data, can be influenced by irrelevant attributes, may assign zero possibility to unseen events, leading to poor generalization. The next point is applications of naive-Bayes classifier. Spam email filtering classifies emails as spam or non-spam based on features. Text classification used in sentiment analysis, document categorization and topic classification. Medical diagnosis helps in predicting the likelihood of a disease based on symptoms. Credit scoring evaluates creditworthiness of individuals for loan approval. Weather prediction classifies weather conditions based on various factors. As we reach to the end of this article, here are some important points to ponder upon. In spite of their apparently oversimplified assumptions, naive-Bayes classifiers have worked quite well in many real-world situations, famously document classification and spam filtering. They require a small amount of training data to estimate the necessary parameters. Naive-Bayes learners and classifiers can be extremely fast compared to more sophisticated methods. The decoupling of the class conditional feature distribution means that each distribution can be independently estimated as a one-dimensional distribution. This in turn helps to elevate problems or evaluate problems stemming from the curse of dimensionality. So that's all for today. Hope you must have got an idea of what is naive-Bayes classifier and how it works. Thank you for listening me patiently. Let's meet during the next video or during the next session.